Good afternoon. It is in fact noon. Thank you for joining us for our conservation webinar series. Today we're actually having a surprise presentation with Dr. Matt Helmers, Professor and Extension Agricultural Engineer at Iowa State University and the Director of the Iowa Nutrient Research Center. He's going to be sharing, does climate change our water quality challenges and design of drainage systems? With that, I know he'll have a quick announcement before he dives in, but we appreciate you joining us today as you do every Wednesday at noon for our series. And I'll turn the virtual floor over to you, Matt.
Okay, thanks so much, Liz. And I'm happy to be here today, although I wish it was in my other capacity that I'm frequently on here as a moderator. If again, as I said just a minute or two ago, if you logged on today for the presentation about the green infrastructure, which I know I was really looking forward to, there was something unexpected that came up, and we weren't able to have that webinar this week. So Elena is working to get that rescheduled, and we will, as always, let folks know about that through the blog and so forth when that's rescheduled. But if you're on or getting on or for that webinar, that will have to come later. And I apologize because you got the B team here today, but we did want to have a webinar, and I thought I could jump in, and this is a presentation that I gave in 2022 to at the Ag Engineering, the ASABE Ag Engineering, the community to the Natural Resource Environmental Systems technical community. It's not going to have a tremendous amount of in-depth analysis, but kind of looking at maybe some thinking around changing climate and the impact that could have on some of our water quality challenges and design of drainage systems. And a lot of this looking at some of the data we've been really fortunate here at Iowa State University to collect over 30 years. Many times we have a 3 or 5 year project. Well, we have some projects going on 30 years. And so, it allows us to look at kind of how some of these systems perform, or how, drainage responds under wetter and drier conditions. So just a second, all right. So I guess, I asked this question, does climate change our water quality challenges and design of drainage systems? It's kind of a weird title, but, I think we could answer that question, and I can save everybody 30 minutes and we can say, yes, it's gonna, right? But, maybe we want to think about it a little bit more than that, or a little in depth. I just, kind of couple slides here that in case folks are interested, some resources that they might see out there or could be useful. The first one is from the USGS total nitrogen loading to the Gulf that summarizes the annual loads, the flow normalized loads, and the 5-year moving average. And one of the things that I think is useful for me as I look at this is how that load really varies from year to year based on how much rainfall and flow that we get. So we look at a year like 2019, a very wet year throughout the basin. The Mississippi River Basin, had a very large load of total nitrogen down the river. We can contrast that with something like 2012, which was, a very dry year, way back to 2020, a dry year. And we see a lot lower load going into the Gulf. And so I think this really illustrates, in this, as we look at that flow normalized load, or flow normalized load, which would be the load divided by the flow, we can see that's a little bit more stable, whereas the absolute load varies a lot from year to year, really going to be driven a lot by the precipitation that we have. As we look at then just another resource, maybe not quite as relevant here in thinking about the variability in load, but this is just the area of the midsummer bottom water hypoxia zone from 85 to actually this is now 2023. And again, you can see that vary from year to year. And if we look at here's 2019, if you can see my cursor, that was a year with a large load, and a pretty large areal extent of the hypoxic zone. Okay, now as we start to think about the upper Midwest, we have to recognize that we have a lot of drainage. Some areas it may be surface drainage, but a lot of areas it's subsurface drainage, artificial subsurface drainage that is going to take most places nitrate with that water that moves through the plant root zone. So here is a map from the transformingdrainage.org, just illustrating areas to the likely extent of drainage across the upper Midwest, potentially drained, likely to be drained areas. And as I said, a lot of this is subsurface drainage, but in some of those areas, there would also be some surface drainage. Okay, so now let's start to kind of think about what kind of precipitation changes we've had, and with Iowa Nutrient Research Center, Malcolm Robertson pulled out for the different crop reporting districts in Iowa for the period of record what we've seen with some of the annual precipitation patterns. And as we look at this is for central Iowa, and so if we just looked at kind of a linear trend line increase, we can see that the annual average precipitation is increased in the late 1890s from, about 29.7 inches, about 30 inches to about 36 inches. So about a 6-inch increase over that period of time. And you can see, it's definitely variable, but in general, that trend is for that trend in the historic precipitation is for increase. So, a 6-inch increase. So, that's somewhere around, a 20% increase in precipitation. I kind of bring it up that way because we'll kind of relate it to drainage. So, maybe a 20% increase in precipitation. But the period when we see maybe the greatest amount of precipitation, as we look at that historical information in central Iowa, and this is fairly similar throughout the different crop reporting districts, maybe even more so in northwest Iowa where I grew up, even a greater percentage increase in precipitation. But we can see this one going back, that linear trend line there of increase in about 2.7 inches from the late 1890s to more modern day. So we had about a 6-inch increase if we look at the annual, but about 2.7 of that coming in the spring of the year. So as we think about this, what might this increase in annual precip, but also that increase in spring precip mean as we start thinking about nutrient loss and our drainage design systems? Okay, and so what we've we have about 30 years that the work that was summarized by Ryan Gokin in this publication from 2015 in Applied Engineering and Agriculture was about 20 years, where we at our Gilmore City site we related the April, May, and June precipitation to the subsurface drainage that we measured at that site. So in this case, each of those dots is a year between 1990 and I think 2021. Somebody can count the dots on there to see if we have actually 21 or how many. Okay, so the one on the left is April, May, and June. The one on the right would be annual precip or the annual precip versus the drainage for that. And that drainage is not, it would be the annual drainage, although we don't or didn't monitor a lot in the winter up there because things were frozen, and the type of monitoring we have doesn't respond well to freezing conditions. Okay, so if we just you can see a lot of scatter around that line. Okay, so yes, it's not a real tight distribution, but there's a trend toward higher drainage with higher precip. So, one of the things, if we had, long-term, that 6-inch increase in annual precip, that might result in a 4.5 increase in drainage. Now that's over 120 years, so that's over a long time period, but we still would project an increase in the amount of drainage. What's maybe more uh, important in some ways is that 2.7-inch increase in April, May, and June, by those projections, result in a 2-inch increase in the amount of drainage. So I violated one thing that I really dislike when any of my students do it, and I noticed that today. I have two different scales on this graph, okay? So the one on the left, the scale is 0 to 20 inches. The one on the right is 0 to 30. They should have been the same, because what you would find then is that the slope of the one on the left is steeper. Okay, so meaning that any increase in precip in April to June period may result in a greater percentage increase in drainage than just happening on an annual basis. Okay, now why is that important as we start thinking about water quality? And I think that again, it makes sense. This is not necessarily anything new, but as we relate over in this case here 30 years of nitrate load to drain flow, you can see that as drain flow increases, our nitrate load increases. Now this makes sense because they darn well sure better be related, or that as one increases the other, because drain flow is used to make up the load, because the load is the concentration times the flow, which is a drain flow. But this just illustrates, if we got a 2 or 3-inch increase in drain flow, we would expect to see an increase in nitrate load. So any increase in precip that leads to an increase in drain flow, we would expect to increase in nitrate load, which is, again, a concern as we start thinking about our water quality challenges. Okay, and so some of the projections are, and as I've been been highlighted to me recently, there's a lot of uncertainty around this, but some of the projections are for increases in humidity in the spring through the mid-century to increase that rainfall, which could increase the potential for soil erosion and further reduce planting season work days due to waterlogged soils. So I think that's right in line with concerns about our water quality. More there on soil erosion and on planting, but we'll talk here about the nitrate side. Okay, and they're projecting potential for a 9% increase in spring precip, 8% decrease in summer precip. So shifting of when we get that precipitation. So our annual precip may not change that much. So if we were to think about relating it back to drainage versus annual precip, maybe that precip on an annual basis doesn't change. But if we shift it to the spring, we may still have some water quality concerns. Okay, and this is where we can kind of think of it this way. So looking at it over those from 1990 to 2011, plotted here the ratio of drainage to precipitation. So if we had 10 inches of drainage and 30 inches of precip, that ratio would be 0.3. And if we look at it annually, that's about what it is. About 32% at Gilmore City, at this site in north central Iowa, over this 21-year period, about 30% of the precipitation resulted in drainage. Now, some might say, okay, how applicable is that? I would say that's a little on the high side, because we have a drain spacing that is pretty close, 25-foot drain spacing. So, if we had a little bit more maybe common drain spacing at our site, we might expect something closer to 25%. But anyway, 25 to 30% of our precipitation at this site resulted in drainage. But if we just look at April, May, and June, about 54% of the precipitation resulted in drainage. And this makes sense. Again, like I'm not necessarily telling anybody something they don't know. This is like kind of of course, Matt. But maybe putting a number on it. April, May, and June, we don't have much plant water use out there. We don't have much transpiration by plants, so that precipitation that falls, there's just a few places for it to go. Some of it's going to recharge the soil, recharge groundwater. But once that's recharged, then we have excess water in the soil profile, and it's going to result in drainage. So, so if we get those increased spring precipitation, a greater percentage of that is going to result in drainage. So that, kind of a concern as we think about our nitrate loss to our downstream water bodies. Okay, and so, one of the things we can also think about then is, if we see increased spring precip, where might this be of greatest concern, or where do we see parts of the Corn Belt where spring water flow and nitrate loading is the biggest, where we might exacerbate some of our problems? And so this is some data that a number of us drainage researchers across the Midwest have been involved with compiling, looking at drain flow and nitrate load from South Dakota, Minnesota, Iowa, Missouri, Indiana, and Ohio, and even down into North Carolina. And maybe one of the biggest things I wanted to illustrate here was that in hardiness zones, in kind of 4B and 5A, which Iowa and into Minnesota and South Dakota and even Missouri, what we see is that those spring periods, we see between 55 to 77% of our drain flow, 60 to 74% of our nitrate load happening in that time of the year. Let's contrast that with eastern in the Corn Belt, where they see 50% of the nitrate load and 50% of the drain flow, 40% of the nitrate load in the winter months. Things maybe don't freeze quite as hard. They're maybe not quite as dry going into winter. So if they have precip, they can have some drainage. But I think as we start thinking about, increased spring precipitation, we really need to be concerned in this western part of the Corn Belt when, that's a period that historically we've had a lot of drainage. Historically, that's when we see a lot of nitrate load loss, and we need to be, that may be exacerbated in the future. Okay. One of the things that is also kind of interesting that we've seen as we've reviewed this database of sites across the Midwest. So these are really, most of these are kind of field scale sites of drainage. And maybe one of the things that this isn't a case where it's maybe the bad news that I talked about or concerning news that I talked about before. But as we looked across all of these sites, we didn't see as much seasonality in nitrate concentration as maybe what we would intuitively think that, say spring of the year after we apply nitrogen, that's a period that we see the highest nitrate concentrations. We really see it pretty similar across seasons. In fact, there was no statistically significant difference across seasons as we looked at these sites, these many long-term drainage water quality sites across the upper Midwest and even into North Carolina. Okay, so one of the things that I think is somewhat interesting is if you dig into the EPA Science Advisory Board report, and kind of maybe that's the second part of the quote that's always something that I'm reminded of, is it said, for nitrogen, the greatest emphasis should be placed on reducing spring flux, the time period most correlated with the size of the hypoxic zone. So, this was released 14 years ago, I think, was when the Science Advisory Board report was released. Certainly, as we think about things going into the future, reducing that spring flux is important. And as I've shown, any increases in spring precip may have a disproportionate impact on reducing spring flux of nitrogen. So, as we think about it, though, what are some things that going to get here to, like what are some things that we can do to maybe mitigate some of that increase? And so, some of our things with 4 Rs of nitrogen management might become more important. And thinking about, can we go to even more in-season placement so that we're maybe outside of that heaviest rainfall window, and that we might see some benefits there. We've seen a bit of benefits on in-season side dress on reducing nitrate loss in Northwest Iowa, reducing it about 15 to 20%. So that's kind of encouraging. And can we do more of that type of work? I think that things like cover crops, perennial ground covers, diverse crop rotations, can help protect the soil and reduce that risk of nitrate loss in the anytime, but really in those spring periods when we try to have something more growing out there during that period when our as we see in the background there, our annual cropping system is more brown, and we see our cover crops green in the foreground, using some water, holding nutrients in the soil and helping us reduce soil erosion. Now, I would say all of these edge of field practices also provide us great opportunities to intercept that nitrate. And, all of those can function in that springtime of the year. But we need to recognize, some of them perform a little better when it's a little warmer to promote the denitrification process, but they still can be effective during that time period. So I think that, they still are a practice that we really need to think about and may become even more important in the future for helping us. Okay, and there was in the 2018 fourth National Climate Assessment impact risk and adaptation in the U.S. There was one comment in there: there's no strategies currently available for maintaining historical trends in commodity ag production to cope with increases in spring rainfall and summer heat waves. So this is, an opportunity to say, well, there may be, but there's a lot of work needed to understand the impacts of this specific practice or cumulative impacts. But a number of us, including Chris Hay at the Iowa Soybean Association and then other researchers throughout the region, are looking at drainage water recycling, where we capture that drainage water, put it in some type of storage reservoir pond, and then we apply a portion of that water out as supplemental irrigation for the crop. And that could be applied different ways through sub-irrigation, center pivots. A couple things here is we're probably not going to store all the water. So it's not a zero discharge facility. So we are going to still, discharge some water because we're probably not going to need to store that much. Also, the water that we store in these is probably water that would have gone downstream in the spring of the year, not necessarily water that would be going down in the summer months when we might have lower flow conditions, but still something to think about. But this might be an area where our drainage design or management might change with potential increases in spring precipitation and drier summers. And maybe we can store some of that spring drainage and use it for supplemental irrigation for the crops. And we are actively looking at research in this space. So the controlled drainage and drainage water recycling have the potential to, since we're keeping that water there, we're decreasing downstream water flow, at least the annual flow, but we really, in the future want to look at, what might be the impact on downstream seasonal flow. But then if we're keeping that water there and sending it back out into the field, we are decreasing nitrogen and phosphorus export from those agricultural lands because we're reusing that water. As we think about drainage design, and I think there's some opportunities for additional work in this because the first work we did in it was long ago, and I think our ability to model some of these systems, both from the climate side as well as the drainage side, are improving. But what I guess I would highlight is these gray bars. So these are the two sets of gray bars are different weather models there. One with contemporary climatic conditions, one future. The SEW 30, excuse me, boy, the SEW 30 is kind of an indicator of excess water stress. And so in both of the climate models, it's predicted that SEW 30, or the excess water stress on the plants, would increase. So this may lead to increased drainage coefficient or drainage intensities. And, many of these systems are already under design. So, maybe even more more impetus for landowners to think about that as they move into the future, so that with those increased spring precip patterns, may have more concerns about excess water in the spring of the year, and timeliness of operations, and it may lead to increased drainage coefficient and intensity. Again, I think this is kind of an area that to think about a little bit more in research as we move forward. So as we look about this, does climate change our water quality challenge and design of drainage systems? As I said 30 minutes ago or so, yes. And you could have gotten off there and not had to listen to me for the last bit, but kind of summarizing it, many of the projections that are out there for increased spring precip and drier summers, I think this could lead to greater drainage volumes. Even if we have the same annual precip, if we have greater spring precip, it may drive slightly greater drainage volumes and greater nitrate losses, just because that precip is coming at a period of time when we don't have much growing out there. And what we've seen is that if we get precip in that spring period, a greater percentage of that goes to drainage than if we got a comparable amount of rainfall in the summer in general. So I think this could add to our challenges. I think that the range of practices that we have that we'd be using now are similar in the future, but we might want to consider how the design to consider that potential increased precipitation. And so I think there's a lot of room for additional modeling and analysis of that. And I think future drainage design may need to consider that increase, the potential increase in spring excess water, both from what that does to the plant itself, but what that may mean for field days and work days out in the field, it may mean that some of the we may need to go a little bit narrower, a little bit higher drainage coefficient, if the goal in those specific cases is to optimize the yield out in the field. Okay, with that, I can go through this, Liz. I'm so used to it. If you watch this webinar, you had to sit through me, and you want to earn a CCA CEU, please email Alena Whitaker, ALENAW, at iastate.edu by 5 o'clock today with your name, that name you entered to watch the webinar, and your CCA number. Again, ALENAW at iastate.edu. If you watch this webinar live and it's your first one in 2023, if you'd be willing to fill out a demographic survey, we'd really appreciate it. This is part of our participation in USDA funded programs. So you can go to iowalearningfarms.org/survey, or you can scan that QR code. And I'll leave that QR code up there just for another second in case somebody wants to do it. If you've done this already in 2023, thank you very much. Really appreciate it. If you haven't and are willing, we would thank you for doing that as well. And next week, Jackie Comito, Iowa Learning Farms Director, is going to be talking about water issues in Iowa, thinking about that urban-rural divide, revisited based on some listening sessions and what she's heard as part of some listening sessions over the last year plus time. So be sure to join in to that. Okay, Liz, do we have
Excellent
questions here? Yeah.
Yeah, and I'm sure maybe a few came to you as well, but Dennis Toddy added to the commentary about precipitation that in Northwest Iowa, we have already seen the shift occurring with precipitation amounts falling off in July over the last 30 years, mostly in the last 15. So Yes, other folks are monitoring that as well. So the question about your Gilmore City
Yep.
study, did it include assessment of fall precipitation prior to the spring?
Um, Not in what I did right here, and that's really as in fact, I was kind of thinking about this as I was looking through the slides on Monday in saying yes to give this talk. That would be um, a really important factor in that, I think, in that spring drainage, because if you've had a wet fall, I think then what I would expect to see is that you would get more drainage per unit of spring rainfall than if you had a dry fall, because more of that rainfall in the spring is going to go toward replenishing. So if it's a dry fall, uh, then more of that spring rainfall is going to go to replenishing the soil profile, or either groundwater or just you know plant available water in the crop root zone. So short answer is it didn't, but I do think it should, as if we start to look at this in a little more detail. We've got 10 more years of data since some of that work was published, and we also have it for some other sites in Iowa, now going on close to 10 years. So actually sent some of that to Chris Hay, because we're kind of starting to think about what might we expect for drainage, for our drainage water recycling system. And so some of those drainage patterns might be important. And I think in that too, we might want to look at fall precipitation as well.
So that's a great segue because we actually have a question about drainage water recycling.
Yep.
How much of the nitrogen is lost while being stored in the storage
Uh,
basin?
that's a great question. Tune into a future webinar and we'll talk about that in more detail. Actually, a grad student has been looking at that. Tyler Meyer has been looking at that at 3 sites throughout Iowa. And we are seeing, pretty substantial nitrate reduction of that water. I just can't remember off the top of my head. I should know, but I can't remember the exact percent reductions. But the 3 different systems are a little bit different in how they were built and constructed. So they're all getting water from a little different sources. But we are seeing, as that water sits in those ponds, the nitrate concentration is reduced. And then, some of them are not discharging downstream. They're, any of the water in there is going back into the field, because in those cases, we're not capturing all the water from the field. So they are removing nitrate. Stay tuned for more summary of that, because we're working on, Tyler's working on summarizing the 2023 data, which we will have 3 sites. Last year, we had 2 sites.
All right. Are there resources on constructed wetlands and how effective they are for capturing nutrients and sediment, especially during the spring and fall months?
Yeah. Yep. So Bill Crumpton. So we would count on wetlands as a nitrate reduction practice. We would not necessarily long-term count on them for phosphorus reduction, sediment reduction. We certainly would see that, but hopefully we don't have a lot of sediment coming in there, because that would be taking up storage volume. But Dr. Crumpton, has a data set, was at 59 site years, where they really do year-round monitoring, and their performance data includes, the spring of the year thrown in there as well. So I think that he's the best resource for that information, and he has a Journal of Environmental Quality publication from spring of 2020 that really lists that. If you get in touch with me, we'd be able to get that to you.
Excellent. So those are the direct questions I had. Maybe 1 or 2 slipped into your chat.
I do have some, and some good ones here, because there is one about the. So I can answer part of this. The last 2 years have had more or less statewide drought. Rivers have run at or below normal base flow for much of the year. uh, and little to no groundwater recharge. Are we looking at a very different scenario than the one based on historical and projected precip drainage and nutrient loads? Well, I guess that'd be a question kind of what's going to happen in the future. I guess, a couple things I would talk about is I think we all need to understand when we start to get precip again, I would expect our nitrate concentrations in the stream to go up pretty dramatically because we've gone through 4 years of drought. When we start getting a lot of water movement through the profile, we're gonna be moving a lot of nitrate with that. So I think that's a um, big aspect that we need to think about. And certainly as we think about some of these drainage water recycling, some of the things that we're thinking is um, this is or some of the last couple years are examples of we might not have had enough water to store to apply as supplemental irrigation. So those multiple years of drought may even impact how we could use some of these practices, and that's certainly something why we want to look at least some of the long-term data that we have. Unfortunately, probably the one of the longest term 88 and 89 might have been the last time that we had such back-to-back droughts. I don't know that I remember. And unfortunately, we don't have some of the drainage data from pre 88, 89 and post. Um, so there is a good question about drainage water recycling. Wouldn't it change or possibly affect negatively groundwater flow to non-rural systems, drinking water supplies, and aquatic habitats? I think that's a really good question and one that we want to look at um, because one of the things is that we're not taking all the water. So we might take 4 to 5 inches of water out of maybe 8 or 9 that goes down a drain. So we would not be taking all of the water. And the water that we're taking, I think in most cases would be water that would be flowing down in the spring of the year. And it's already water that would likely be delivered to the stream through from a drain. So it wouldn't really be impacting probably groundwater recharge in that field if it's already drained, but it might impact maybe some riverine recharge into shallow aquifers there, kind of walking through things I would think about. So I think it is something to kind of conceptualize, and I think in the future thinking about larger scale hydrologic modeling, how it might function. Um, but again, this year is a good example. Our systems, we were able to get them full with spring flow. Then it turned dry, and we used that water for irrigation. We weren't able to capture any more water. So we weren't, it wasn't like any water that went out in July out of the drainage system. We were capturing rather than letting it go downstream. There was just no water to capture. So, I think that because we're taking some of the spring flow off, I wouldn't expect these to have a very big impact on summer flows. But I will acknowledge it's something I think we need to do research on. Um, there's a question here. Oh, yeah. Somebody asked, do you think we should use nitrate soil testing during drought like South Dakota to revise our recommendations? Yeah, I guess I think that any chance we can take to understand what resource we have out in the field and doing some soil nitrate testing is a way to do that. I think that is important as we think about these dry years like we've had, because if we've had a dry year, we may have a lot of residual nitrate. If we have a relatively dry spring, we might be able to count on that for crop production or for part of the crop production. I showed an image for drainage water recycling. Does this impact nitrates as much as phosphorus? I do think it impacts nitrates maybe even as much or more than phosphorus. Are there any ponding projects to be pumped into a bioreactor? Not ponding projects, but we are involved with a couple pumped bioreactor projects, or colleagues of mine are. Michelle Sapir has a pumped bioreactor project, and then um, the coolest pumped bioreactor project, in part because it's way up in the Red River Valley of North Dakota, where they're going to do a pumped bioreactor. So not necessarily from the pond, but they are pumping that drainage water that would have otherwise gone downstream into a bioreactor to promote that denitrification. Um, that's a oh yeah, that Mitch asked a great question. Is there any indication of how climate change has impacted fall and spring mineralization and how that impacts total end loads? I would ask Mitch Baum, Dr. Mitch Baum, in the Department of Agronomy asked this question. Sorry to call out Mitch. But I think that's a great question, and maybe some of the modeling you've done with AppSim might better assess that. But I think that if we do, I was thinking about precip changes, which, but if we start to think about combining moisture and temperature changes, we might, that might be influencing that mineralization and increasing loads from the end. I guess I could talk through that way, but that's a really good question. Liz put in there virtual field day exploring a pumped bioreactor. So we did Learning Farms did a virtual field day on a pumped bioreactor. I don't know how long ago. I was going to say a couple years back. I lose track of time, but with Michelle Sapir's group. So have a look at that if you're interested in the pumped bioreactors. Those are the questions I had directly to me, Liz.
Perfect. Then that concludes all our questions for today. We
Yeah.
thank you all for joining in today. And as we noted, we are working to get that green infrastructure webinar rescheduled at a later time. So again, thank you for tuning in today, and keep apprised of our blog and e-news and other sources to find out when we get that green infrastructure webinar rescheduled. Thank you, Matt, for stepping in and doing the webinar today. I will give you the last parting word.
Okay. All right. Thanks for the opportunity. As I said, this was maybe to more start some more discussion. I think there are so many areas that any of the analysis I did is very limited and lacking, but maybe raises some points. And had Dennis Toddy highlight that definitely have to include that winter soil temperature in the issue as well as farmer decisions. And I would absolutely, yep, that's an excellent point, Dennis. So with that, thank you so much. And I hope everybody has a great rest of the day and week.